Great. Good afternoon, everybody. Welcome to today's research talk. My name is Jesslyn, and I am a student in the Psych Foundation program. Today, I will be presenting our project that I'm currently working on, titled An Exploratory Study of Playful, Rule-Flexible, and Rule-Explicit Problem Solving. See here. The next slide. Okay, so you could access our slide from tinyurl.com, baba-baba-umn. Okay. All right, there are currently 9 of us working in the project. I'm working with Dr. DeLiema, Dr. Kisha Varma, Dr. Godong Chen, Megan Goki, Basil Hussein, Zach Carpenter, and Jennifer Dahl. We also have a postdoc who just recently joined us. His name is Craig Anderson. He's been joining us virtually, so hopefully he'll be joining us soon in person. So to start off, I will introduce you to the game that we're using for our project. The game is called Baba Is You, and we're very fortunate that we are able to get in touch with the creator of the game, which is Arby. And then, so without further ado, we're gonna play some Baba game. Anybody would like to play Baba? Feel free to come up here.
Somebody who is not a player.
First, somebody who's played Baba before. Yeah, okay, come up here and play Baba. Perfect. All right, so welcome, Gina. All right, so you can come here, but you'll just have to play with the bigger screen.
Okay.
Okay, so we can start off you from level 0. All right, go ahead. Try to solve the level.
You use the little keys, the little arrows.
Just use this arrows, yeah. Okay. Yay! All right, next level. Level 1. Where do I go?
You can go backwards with Z.
Yep, so you can press Z. All right. Audience, any help? Any scaffolding? Come on, audience.
Gina, what are you thinking about right now?
We want to get to the flag.
Why?
I don't know. Wind is
I would
flag.
use that, yeah, I would use that. If I were you.
Use that to do
How would you use it, Lisa?
I would put it in between the words win and flag,
Why?
because to win, you have to, winning is the flag. And I'm assuming the little creature guy is Bob. Yeah, one minute. I don't think it has to be on the flag.
Oh,
I think you have to be on the flag.
all right.
Nice.
Don't say sorry, you're problem solving.
Oh, I was wrong. I led you astray.
Flag is what
Oh,
could have
yeah,
happened.
yeah. Nice.
You have to use the other wit or is, right? When it's like lit up. Or is that just saying that that whole Baba is you is activated?
Oh.
Thank you for playing with us. So to just kind of relook at the level again. So in the game Baba is you, the rules are changeable. As you can see here, wall is stop is a rule. So I can't go outside the wall. But I could break the rules and now I could actually go outside the wall. I could also, so right now Baba is you, which I am Baba, the sheep. I could also change myself and become wall is you, and then now I become a wall. I could also, so Gina did flag is win. I could also do wall is win, and then now I could win by touching the wall. So there are lots of ways that you can win within the game of Baba, and there's all sorts of ways that you could change your characters as well. All right, so now moving back to the presentation. All right. Is everything on? All right, so now the short-term objective of our study is the inspiration of our study derives from our curiosity in understanding students' problem-solving behavior in an informal learning environment. As you can see in Baba here, the goals is unstructured. And as we all know, kids are playing a lot of video games and it is a big part of their lives. Putting the two together, we want to better understand how middle school students solve problems in this playful context. In the long run, we would like to understand how families play this problem-solving, puzzle-based video game and problem-solving together. So let's take a quick poll. How many of you in the audience played video game as a kid? All right, so majority of you play video games as a kid. And how many of your parents actually play video games? All right, only like one. All right. So families today with young children are somewhat in like a new territory, right? Like parents will be able to actually play video games with their kids. And we kind of expect this to become a frequent settings for family learning. So in the long run, we're hoping to understand how youth and adults navigate the problem-solving environment in video games. And there are a few reasons why we picked the game Baba is used specifically. It's a really great game for our research long-term agenda. First, the goal is not fixed. While this is novel in the problem-solving landscape, unstructured problem-solving is a common condition in the real world. So understanding how players judge the promisingness of particular goals and adapt, abandon, or replace particular goals is worth examining. Second, the rules are visible and manipulable. These two characteristics together make players' problem-solving approach more transparent than traditional problem-solving contexts. And third, the game offers playfulness and problem-solving. This is not a high-stake game, right? The gamified elements of the problem-solving context, such as the upbeat music, easy restart, and the charming avatars create the condition for a playful orientation to failure. Fourth, the game mechanics are introduced and reused. As players move throughout the games, they are consistently asked to learn new game mechanics and apply them in a novel way. This means that we can see how players actually stretch their understanding and how they learn to think creatively in the system. And fifth, there is a social responsibility for the gameplay. Like the game is fun and you can also play it with others, presents an intrinsically meaningful context to scaffold a player problem-solving approach. And now I will pass the presentation to Dr. DeLiema to present the lit review.
Do we want the lights off or on? No preference. Maybe we'll turn the lights on. No, I think we can off. All right, thanks, Jesslyn. I am going to talk us through some of the literature that we're working with. The first area that we're connecting with is research on play and learning. This is known as a generative context for learning. However, the causal mechanisms that are undergirding this efficacy are really unknown. There's lots of candidate factors. There's allusions to flow in games. There are intrinsically motivating qualities. Sequential skill development. These are really promising candidate factors, but they're not quite precise enough to explain how a player in a play situation is going about solving a problem. That's what we're trying to address in the project. From the play literature, there's a really nice set of constructs that are useful to think about problem solving. There's this notion of operational rules that comes from the play literature. They organize play, and play is about acquiring, understanding, constructing, and then applying these rules during problem solving. Now, problem solving is similarly very often defined as around rules. So rules are the principles that govern the procedures, conduct or actions in a problem solving context. For us, this means what moves can the solver make and what goals are they pursuing. So these literatures don't often intersect. Play is about rules, problem solving is about rules. There's really a space to map them. And you can be a little more precise. So from the games literature, there's a piece of 2003 that distinguishes manipulation rules from goal rules. And in this context, a manipulation rule is what happens when a particular rule is activated. So if you have a rule like flag is stop, it means that you will not be able to cross this border at the flag location. You're just going to get stopped. That's a manipulation rule in the game. It's like, you can think of it as the physics of the game. When a particular rule is active, what can you do, what can't you do? But there's also the goal rules. And the question here is like, what goal are you even pursuing? The is and the when statement are separate. There's actually no goal right now. You know, you might be able to create one, but there's nothing that you can actually pursue in this moment. In Baba is You, the game is so ingenious because they've allowed you to play with meta rules or implicit rules. Meta rules were, I mean, my sense is that they're somewhat like marginalized in most play environments. In many play environments, you're locked in to a particular rule set and you operate within that rule set. In Baba is You, you get choice over how you treat these manipulation rules and goal rules. Specifically, you can take a statement like flag is stop and break it. It's giving you a lot of power over the meta rules of the game to say like, no, I don't want these manipulation rules active. No, I don't want this goal rule active. I'm going to actually tweak it. You put them together and then you can reassemble the environment and achieve a goal, like then creating flag is win and touching a flag. The problem-solving literature, going back to at least 1945, from this classic text by Polya, really set a precedent for thinking about problem-solving as a series of steps. Understand the problem, devise a plan, carry out the plan, and look back. Those are the four, at least, that came up in Polya's text. These are decomposed into smaller actions in the original text, but this is the sort of like tradition that problem solving has maintained. Many folks have like revised these actions, like these key actions, but it has long been studied as a set of moves and then sequences of those moves. One of our collaborators on the project, Shima Salehi, has been working a lot on problem solving, and we've been using her definition as a goal-directed task that one requires employing relevant scientific and engineering knowledge. For us, we would say Baba's U knowledge, and very specific to the game. You do not have a prescribed set of actions to reach the goal. If you open up the game and just enact something, you're not problem solving. You're just doing something that is a known routine and encompassing multiple parts and multiple solution paths. So we're going to operationalize this a bit more carefully, as you see later. Shima has pointed out a number of weaknesses of the existing problem-solving literature that we're running with in this project. One is that there's an over-reliance on domain knowledge in the problem-solving context. Many of this work takes place in like an engineering context, so the amount of engineering knowledge that you know really matters. Bob, as you, nobody knows anything about these mechanics. I mean, there's some like intuitive knowledge about what stop means or what win would mean, but you have to develop your understanding of mechanics from like basically a point of knowing nothing. So we can really see these trajectories of growth. Alongside this first critique, there's a second critique that there's an assumed deficit perspective for novices. There's a lot of research comparing like expert problem solving with novice problem solving. Yes, it has advantages, but this like domain knowledge kind of hangs over the study, and we don't really have that in this play-based context. Shiva also argues there's a lack of attention to metacognitive reflection regarding the selection of problem-solving strategies. We would add two more, that in much of the problem-solving literature, the problem state is fixed, either the goal or like the rules in the game. And that's not really true to the real world. We have to question our goals all the time and wonder if they're worth pursuing. And Bob Aziu gives you just like a hyper precise view into what those dynamics look like. Also, these data interpretation and monitoring and evaluation moves in problem solving where you've done something and then you reflect on it, we think can be anchored more in the causal reasoning literature. You'll hear a little bit about that when we share our framework. We're also building on the literature on productive failure and debugging. We now know that in many settings, failure is a really generative point of departure for learning. There's a lot of like neat work on this, but the mechanisms are still hypothesized. It's actually really not clear what is behind this effect. We know from Craig's work, Craig, a postdoc on the study, has looked at failure in a game. It's one of the best studies in this area. And what we know is that when players get stuck, they start talking more. They start talking with their co-players, and they start talking about the game mechanics. And Craig's able to show the more times you get stuck, the more times you discuss the mechanics, and then that correlates with your learning in the game. Really, really powerful about reaching one of these impasse moments and discussing what's happening. We're also building on Jeff, DJ, and my work on debugging, where we look at these three really well-studied parts of debugging. Simply identifying why the program needs to be fixed is like a huge move in debugging, and it basically is Shima's definition of problem solving. You have to notice that something has gone wrong, that you don't have like an immediate path to the solution. There might then be a period where you search for a cause of that problem, like why can I not move forward? What is in my way? And then a process of planning a resolution. Jeff has been really working on these like really nice visualizations of these three processes. And the reason that we're not going to talk about this today, but I'm bringing this up because the work that Jeff, DJ, and I are doing around debugging is really informing the coding scheme that we're using in this Bob Aziu context. And to just briefly unpack this, you have to notice that something is deviating from preference. Failure isn't neutral. It has to be seen and observed and described in a particular way. And we're looking at Bob Aziu at like what you notice and how you describe that problem. And then there might be a stage of modeling it, like what is causing this impasse. What you notice strongly shapes what you might model as the cause. And what you model as the cause then strongly shapes how you intervene. And we're seeing a very similar process in coding as we're seeing in Bob Aziu. Jesslyn, I'm going to hand it back to you. But in summary, we are weaving together the research on play, research on problem solving, and research on debugging, and trying to form a bit of a lens so that we can understand how players are problem solving in Bob Aziu. Okay, back to you.
All right, so thinking open-endedly, the bottom-up questions at this early stage of our research process, we're asking the question, how do middle school students and college students solve problem in Bob Aziu, especially for a situation in which the approach deviates from expectation and requires revising? So in our pilot study, we have 13 middle school students that we first round. And then we have 12 college students, which we recruited in the second round of data collection. And all of them participated in 3 one-hour gameplay sessions, which we conducted weekly. So each participant played the game for a total of around 3 hours, where they were compensated for $30 Amazon card. All right, and then so now I'm going to talk about the data collection procedure. In the beginning of the study, each participant was then matched with a grad student that will do the data collection for them. The grad student will meet with the participants to go over the setup of the game, which usually takes about 20 to 30 minutes. We collected screen recording, Zoom transcript, and self-report measures at the end of each session when the player is talking and us transcribing later at the end of the session. So these are the self-report questions that we ask. We start off with the questions surrounding your persistence in playing the game. So we kind of ask, okay, do you get stuck at any point? Do the games get difficult? And if so, like, how hard did you try to find a solution? And then followed by questions surrounding the breadth of problem-solving strategies. So we ask, how do you try to find a solution when playing Baba? So it's more open-ended. And then we ask them, so let's imagine if you have a friend who wants to play Baba, what advice would you give them? And then we do ask a question about information gathering at impasses. So if you get stuck or the games get difficult, what did you do? And lastly, we ask questions regarding their self-efficacy. It's gonna ask them, okay, you're gonna play Baba in the next session, how well do you think you'll do? We give the options, there's no way I'll be able to solve. I might be able to solve the next level, I will probably be able to, or I'll definitely be able to. And we have 3 gameplay sessions. In the first gameplay session, students and the researchers will go over several introductory levels together, which we will introduce them to the mechanics of the game. Students then kind of engage in a think aloud protocol where we specifically analogize to a YouTuber or Twitch streamer when they're solving the levels. They're allowed to ask for assistance from the researchers when they're really stuck. And when they ask for help, researchers will then provide scaffolding by making connections to previous levels or what they already know about the game mechanics to help them successful in the current level that they're working on. And then in the last 5 to 10 minutes of the game, the researchers do the interview with the self-report measures about their gameplay experience. So the same procedure is repeated throughout the second and third gameplay session. The difference is just we skip that introductory part and player just continue picking up the game wherever the level that they left off in the previous session. So following data collection, the self-report interview were then transcribed and uploaded to Qualtrics. The video footage was cut into clips by each level. We then picked 2 levels, specifically float and changeless, based on the following criteria. So float is the one on top, changeless is the picture in the bottom here. So these are the 2 levels that we pick based on the criteria that we set. The first criteria is that these levels are encountered usually in day 2. So they usually have a good grip on the game and they have some gameplay experience under their belt. In these 2 levels, they're introduced to new game mechanics and that these levels also solvable in less than 5 minutes. And then each of these levels were then transcribed multimodally and analyzed according to interaction analysis conventions to document the publicly expressed nuance of problem solving. So this is what conversation analysis transcript look like. For example, we have a sign for intonation, uncertain moments, gaps, and pauses with all that dots, question mark, commas. So there's some more conventions that we use, colons, up arrow, down arrow to represent pitch. And again, more conventions. We also adapt the conversation analysis transcript conventions and create our own conventions to describe the movement of our gameplay session in greater detail. So for example, we have Baba dash like, okay, so Baba dash is you, and then underneath it we have Baba is dash you. So that's kind of represent the movement. So Baba and then breaking it off to is you, and then underneath it it's representing, okay, Baba is, and then breaking it off you. And then, so is it important to know which word is moved? Is the break? So that's kind of like what we're thinking as we're creating this transcript conventions. We also have like this flag is rock. Rock is italicized and underlined. Italicized rule indicated change that was a result of pressing undo. So we think it could be important. And then same thing, we use more conventions to describe our study. And then so to put it into context, this is an example of a multimodal analysis approach that we use. In here, you can see parts that are folded, and then there's like two brackets here. Baba moves and flag turn into rock. So this is to describe movement. And then down here, it's actually representing like an utterances. And here it says there's a sharp increase in pitch, and then say oh, and then it's kind of elongated oh, and then there's a pause of 1.5 second. So that's kind of like how it's represented. All right, so now going into part one of our data analysis, which is transcribing and categorizing. We developed the transcript conventions building on conversation analysis method, which I just showed you. We then transcribe float and changeless level from both college and middle school data. We then shared the transcript with other members of the team as an inter-rater reliability process, and then followed by discussion and refining points of disagreement in the transcript. In the second part of our data analysis, we worked over several months analyzing other bubble levels to develop the problem-solving framework. The framework is strongly shaped by the, again, debugging research along with the playful literature and the problem-solving literature. We then also modified our framework over several more data sessions, and our goal was to describe key moves player made in problem-solving process. So this is what it looks like in our problem-solving framework that we developed. There's a lot more than just this, but I'm just going to give you a rough idea. We constantly developing this, and this is still an ongoing process. We have our puzzle environment here, and then again we have our initial state, and then different types of rules that we use. And then we have a puzzle approach, which is orientation, a goal-oriented action. We have noticing deviation, action revision, and causal explanation. And then we also have reflection. Now going into data analysis part 3, the subsequent data analysis process blends interaction analysis method with top-down approach to coding the data. We have the inter-rater reliability process as a team of 5 coders work together on the same few levels. We then broke off into dyads where each members of each team coded the same transcript. And then we all kind of come together and then compare our coding and resolve disagreement. We then also brought up the disagreement that we have to the full team to refine our framework again. So we work in this kind of thing over and over again to finalize our coding system and throw out all the changeless and float level. So we coded our data either using ND, CE, or AR. I will start off with ND, which stands for noticing deviation. When a player notices a deviation but does not describe what the deviation is, we code it as ND1, so the very basic level of noticing. If it describes what the deviation is, we then code it as ND2. And if they completely describe the deviation in detail, such as I pushes the rock and then the river and the rock disappears, and then we code it as ND3. CE stands for causal explanation. CE1 is when a player proposes a plausible cause of deviation but does not elaborate. We coded CE2 when the player provides elaboration of the possible cause is doing, and CE3 when the player references their elaboration and connects it to the deviation that they notices in light of the new causal explanation. We also have AR, which stands for action revision, and SR for successful revision. We coded SR specifically when the action leads to winning the game. For the rest of it, we put it as AR. So we coded AR1 when the player revises their approach without providing mechanistic explanation. AR2 when they make revision and accompanied by partial mechanistic explanation. And AR3 when their revision accompanied by a complete mechanistic explanation. We also log all discrepancy in the coding system and track changes to see where we struggle in developing our coding system. So we have some discrepancy here, for example, line 25 and 26 of the transcript. This player has previously described 2 deviation. I can't touch wind. So it says can't touch wind things and can't push rocks. So the statement in this moment appears to be consolidating with previous knowledge, and then that moment is a causal statement. So like, where do we actually code it? So stuff like this, we bring it to the big group, and then we kind of discuss together where it fits in our coding system. Or if it doesn't fit anywhere, then we maybe create another coding. So yeah, that's kind of like how the process is. And then these are kind of like more refinement of our framework. All right, so now the last part of our data analysis, which is where we aggregate the data representation. These are pretty exploration right at this stage. We're again still work in progress. We aggregate survey results to understand how player experienced the game. We then selected transcripts to provide the reader with examples of how we applied the framework to the data. We then aggregate average and standard deviations of framework and categorize them according to groups and levels. And lastly, we conducted sequential analysis to begin to understand patterns of problem solving. So now going into findings. First, this is from our self-report questionnaire. Almost everyone said that they get stuck every single session. There's actually only one session of one person that says that they didn't get stuck at all. And then almost all of them also said that the game gets difficult as it progresses. Most of them said that they try very hard and they solve the level, so that's good. And then we also have some varieties here when we ask them how will you do next time. Some said I will probably be able to solve, or some said I might be able to solve, I will be able to solve. What I noticed is too, in the beginning of the game, in the first gameplay session, they're more confident. Like, okay, I'll be able to solve the next level. But then as they progresses on session 2 and session 3 of the game, they like go down, like, okay, I will probably, or I might be. All right, so this is an example of transcript from the changeless level. So I'm kind of going to guide you through it. First, we have in line 1 that represent the first moves that the player did, line 1. So Baba moves and flag turn into rock. So I have a screenshot here to kind of reorient yourself. We have the flag here. So as soon as Baba moves, this flag turned into a rock because there is a rule that says flag is rock. So it directly changed flag into rock. And then it says rock is rock. So in this level, the player were introduced to noun rules, which is rock is rock. In line 1, when the player makes their first move, the flag again turns into a rock. And then in line 2, we code ND1 here because we see the player says, oh, so we're thinking that the player actually notices that it turns, but it just says, oh. So we just code it as noticing a deviation, but it doesn't have any extra elaboration, right? But then on the next line, the player says, okay, flag turned into rock. So that explicitly saying what is the deviation. So it puts them at ND2. And then on the next line, it says, so I'm going to change that. And then the flag is, and then break the rock. So flag is, and then break the rock, which is, we code it as an action revision. All right, and then last one, oh, actually, the fifth one, we have the participants showing that the eye widens. We call it noticing deviation. So when this happens, maybe it doesn't go according to the plan or whatever the goal that the player have in mind. So then this is kind of like another shocking experience that the player is having, another noticing deviation. And then the player kind of explain it. I can change that because it's gone. And they make it into CE. Because it's kind of, because it's gone, it's an causal explanation. Any questions? I know the transcription's kind of hard to understand for people who are not used to it. All right. So this is the float level. So we kind of like go through the same process. So I'm not going to go through it line by line. But you can also see, oh, because Baba is float, we code it as causal explanation. And then this actually has a reflection verification. And then higher level CE and AR. Okay, so this table is the average player statistics by level and age. For example, the average college students playing changeless would notice a deviation at level 1 about 4.1 times a play session with a standard deviation of 2.8. So we have this number here. Middle schoolers and college students are producing causal explanation at the same rate. Also found that college students ever so slightly give higher rates of high level CE or just more consistently compared to middle school students. These are some exploratory observations that we made and the question that we raises. First, that we noticed that there are more low-level NDs and AR compared to the higher level ones. However, we see more higher level of CE. So the question is, what is it about causal explanation that nudges player towards more specificity? Second, many fewer causal explanation than deviation noticing and revision. The question that we ask is, when do player explore causal explanation? Why are we not seeing an even distribution between ND, CE, and AR? Third, each level involves several deviation and noticing. So defining the problem is not front-loaded all at once. Problem are successfully noticed as the player explores. The question is, why do players shift that are kind of a rarer form of more detailed deviation? And then through lab sequential analysis, we can see the sequence of movement. So here's an example. ND1 followed by AR1 happens 21 times. So that's quite a lot. And then you can also see that AR1 followed by ND1 happens 26 times. So this is showing the connection between the flow of ND, AR, or SR, CE, and all that. And then in changeless, as a level prompt more deviation noticing and action revision compared to float as a level. We presume that because we see ND followed by AR kind of more often here in changeless versus down here in float. So perhaps an obvious observation, but there are also lots of ND. We might naively expect the problem solving is about defining a problem once and then solving it, but it is clearly a process of noticing that the problem again and again, and then including deepening of noticing process over time. And then more exploratory observation and questions that we raises. We notice that the most common pattern is ND1 leads to AR1 and vice versa, AR1 to ND1. So why is this a pattern? Is this a game fluency effect when this kind of exploration is typically valued? Why do we skip causal explanation? Like, what does this tell us about problem solving? When will this approach fall short? Does the pattern change over time? How might this finding align with research on thinker? And then we also notice that NE1 and NE2 and 3s are the most common precursor of CE1 and CE2 or 3s. The question that we have is, what is it about those noticing deviation that sparks a search for a causal explanation? And then the third thing that we notice, CE1 is never leads to ND. They almost lead to AR. The question is, why is this the case? There are questions, so all of these questions are questions that we are yet to answer. Okay, so now for future directions. Right now, we're working on collecting more data this fall. Hopefully starting up soon. We're also interested in looking what types of scaffolding is effective in improving students' problem-solving approach, and how does it actually influence their ability to solve the next level. We're also interested in incorporating eye tracking data. Zach has been playing around with it more, and here's an example. I'm gonna see if I can play the video. All right, so did you see? Okay, so this purple line, purple dot here is where the eye is looking. All right, so we think that eye gaze data would be very helpful in our study, because then we'll know exactly where the students are looking at in connection to your thinking and your verbal. All right, so those are it. All right, so thank you for listening to today's research talk. And if you have any questions, ask your questions. All right. Let's ask first, okay, Gina.
So I saw that on the slide with the research questions that you guys were looking at both middle schoolers and college students. I just wanted to know why that was the groups of participants that you were looking at, like age-wise, or if you were maybe gonna compare them, or just more details about that.
At first, we have thought about looking if middle schools and college students would approach problem solving differently to kind of see like maybe expert players to novice players, but we don't really see that. We see kind of like the same general problem solving patterns, because we also think that these are new novel problem solving environment, so it doesn't really have like gain through like problem solving expertise or anything like that. But yeah, that's kind of like the thoughts when we first started off. Other question? Yeah.
You laid out some of the reasons as to why Baba is you was kind of perfect for this type of research, but I'm wondering if you could explain a little more about why it was chosen. Was there previous research that has used this game? Were there other games you were considering?
I don't think that there was other game we're considering. We kind of like stumble upon this game. Jen brought it up. And introduced that to David. I think that's kind of what happened. And then David thinks that we could learn a lot from this game, and that's kind of like how the project started.
Just to build on that a little bit, there's some problem solving research in other video game contexts. One is the game Portal. That's like a really tough puzzle game and really neat like work that has been done there. This just jumped out as like the most incredible context because the rules are on screen and players are interacting with it. So you have to just make many fewer inferences about the player's thinking than you would in many other problem-solving contexts. And because we had the connection to RV has been able to give us access to the log data. So we now have like, within our next data collection round, we will have all of the moves the player is making, and we wouldn't have had that collaboration with other games. So it's in some sense, you know, partly that relationship, but also, you know, the affordances of the game.
There is a Zoom question.
Yeah.
Oh, there may be a Zoom question.
Don't type.
Yeah, I can say it out loud too. Can you all hear me?
We can hear you.
Oh, yeah, we can hear you.
All right, great work, Jesslyn, David, and team. This is really cool. I'd wanted to ask a quick question because I noticed on the winnable state / goal rule slides that it looks like you or win can be the object. But thinking about Gina's playthrough and reflecting how in that level 1 playthrough, flag is win is correct, but win is flag is incorrect, which to me seems like obviously a game mechanic, but a weird English thing. Do you think that game mechanic influences what you're noticing in how participants approach problem solving and what they might have communicated to / shown you? Because to me, win is flag should be correct too, in my opinion.
Right, so there's still constraint within the game, right? Yeah, when is flag doesn't activate the rule, but if you change it to flag is when it activates the rule. But when we see noun to noun, it's activated. So yeah, there is definitely some like constraints within the game that not 100% manipulable, I should say. Anybody would like to add people in the project?
Yeah, I would say,
You might need to walk up. Maybe, sorry to.
no worries.
We can hear you actually.
Oh,
pretty
you
well.
can?
Oh, okay,
never
well,
mind.
I'll go back easy. I would say that part of what made us interested in this game and part of what we're paying attention to is when do the players themselves notice something as problematic. That's the noticing deviation. So in Gina's playthrough, she attempted that win is flag, and then you have that moment of like pausing or moving over the flag to check it. And our framework was developed not to say we're going to assume that that's a deviation because we know it's not going to work in the game, but how is the player reacting to it, and then it potentially explaining it. This game does have these larger meta rules and manipulation rules that you can learn. Maybe in that moment, Gina would notice that some of the words have colored words and no background, and other words have backgrounds and transparent words. That actually is part of the way the game works, is you always have to have a no background text as the front word in a sentence. And we're really trying to attune to when do players notice these things themselves? When do they create those causal explanations for what they notice and then transfer them to future game levels? Does that answer your question, Ty?
Yeah, it does. Thank you. So it sounds so in what I'm hearing is that you're focused on the mechanic and the change and the noticing of that change versus the actual content itself. Is that right?
Correct.
Thank you.
And, sorry, Rena, I just wanted to say one more thing, that we picked the game because of these red herrings around the goals. That's one of the big reasons. I'm like looking at the microphone as if you're floating above us. And the reason is like in actual, like life, you can't take your goals for granted. It's possible you have to question whether what you're pursuing will even work and abandon it. And the game just gives us so many opportunities to like eventually study how you choose to abandon something that might have seemed fruitful at one point, but is no longer seeming promising. So your point about affect is a huge one. We haven't looked at it yet. I know Zach might be interested in going in that direction, and I think there's so much to explore there. Yeah, so thanks so much for that question.
Yeah, thank you, David. And that actually goes towards Taylor's question too in there. And part of that is, yeah, if you're looking for the continuation of how a student plays the games, then sorry, to Taylor's point, I'll let Taylor say it.
Did Taylor say something?
Oh, sorry. Can you hear me?
Yes.
Yeah, we can
Okay,
hear you.
cool. Sorry, I wasn't ready. I was just wondering, like, how I read Kai's question was more of like, is it a barrier for like people who don't speak English as a first language to like figure that out because maybe they get caught up on the order of the object and the verb?
I think we did actually have a participant whose English was not the first language, and that participant actually struggled in trying to understand the game mechanics, because probably it could be because of order of operation and all that. But as you can see here, yeah, like all the rules, like flag is win, wall is stop, bubba is you. The one that has a dark background is always goes on the back.
Taylor, we're going to, yeah, that's great. Taylor, we're going to do a better job in the data we collect this fall of understanding players' language backgrounds. It is, though there's no domain knowledge that's relevant, of course there are words and the words have meanings, and it's something that we need to really pay attention to as a project.
Thank you.
So we have time for one more question.
Okay.
I have,
Yeah, Inda, go ahead.
thank you. I have quick question, not really question, but I kind of relate to Ty and Taylor's questions that maybe wording or language is an issue. Then I was thinking, what is your opinion on how problem solving works in other games genres that, for example, there are lots of puzzle games, and when you play Baba Issue, you can automatically identify that it is puzzle game, but then there are also puzzle games that involve storytelling. Either it is verbally, like there are explicit text in the game, or just like in the video games world, there is this environmental or nonverbal storytelling. And I'm just wondering how maybe your hypothesis or opinion on how problem solving will work in different kinds of game like that doesn't require that doesn't have explicit instruction that it is a puzzle game. Thank you.
Greg, you have an idea?
Yeah, can I jump in on this one?
Yeah.
Thanks. So hi, I'm Craig, everyone. So some of my other work focuses on